Hi everyone, it's Liam. Today we're going to be doing another ALEKS guide. In today's ALEKS guide, we're going to be naming the compounds of different ionic compounds, specifically ionic compounds that contain polyatomic ions. So you've probably just been introduced to polyatomic ions. You should have gotten a nomenclature sheet that contains these two pages where you've got polyatomic ions up here and you have some metals. You've got your transition metals in here, their charges of the metals, etc. So these two pages are going to be what you're going to use right now to get through these problems. So when you first come across polyatomic ions, it can be a little overwhelming because there's a lot that you feel you need to memorize. And believe me, you do need to memorize them if you want to continue in this class or in any class involving chemistry. But I want to encourage you not to freak out too much, because if you keep up with your ALEKS assignments and you keep doing your homework and involve yourself in chemistry, you're going to find that memorizing these polyatomic ions will end up becoming second nature to you. You're going to use these so often that you're going to memorize it without even realizing it. So with that being said, let's get into this first one. So we want to find the empirical formula first, and then we want to find the name of the compound. So ionic compounds, as you know, contain a cation and an anion. And in this case, our cation is chromium, and our anion is the polyatomic cyanide. So, how do we write the empirical formula? Well, the empirical formula is all about matching charges. In order to have a compound, it needs to be neutral. So, that means that the positive and the negative have to cancel out. So a good way of doing this is a little bit of kind of cross multiplication, or maybe not cross multiplication. You'll see. So if we have chromium 2 plus and cyanide, which has a 1 minus charge, we can find out what our empirical formula is by bringing the positive charge to one side and the negative charge to another, and writing out our formula. Sorry, it's a little messy, but by putting the charges on either side, we find that we're going to have 2 cyanides and 1 chromium. So you see what I did there? All I did was just bring this to one side and bring the charge of this one to the other. And that gives us the number of atoms or anions on each side. So this is going to be CrCn, and then we're going to put parentheses in here to indicate that there are 2 cyanides in this empirical formula. Okay? So what is the name of the compound? Well, it might be tempting for you to just say that this is chromium dicyanide. This is wrong. Definitely not chromium dicyanide. First of all, when we have a polyatomic ion in the name of our compound, we don't put a prefix in front of it. We just refer to it as whatever the cation is and its, or anion is, and its polyatomic ion that is paired with. So in this case, we'd be looking at chromium cyanide. But wait, there's an extra catch here. Chromium, if we look at our nomenclature, we find that chromium here has two possible charges. It can either have a charge of +2 or it can have a charge of 3. Now, remember this, whenever you have a metal that has more than one charge, we have to state that charge in its compound name. So, as you can see, titanium, chromium, manganese, iron, cobalt, nickel, copper, gold, mercury, indium, tin, lead. All of these have 1, 2 possible charges to them, right? So whenever you find any of these, it's important to specify which charge it has. So as we can see here, chromium can either be 2 or 3, in which case, in our example, we see that chromium is +2. So how do we represent this? Well, right after our chromium, we just put a parentheses and then the Roman numeral of the charge. In this case, our charge is +2. So this is going to be Roman numeral 2 and cyanide. Just note for ALEKS's sake, there's no space here. No space. So it's kind of like one word, chromium 2, right? So that is chromium 2 cyanide, and that's it for the first one. Let's move on to the next one. So here we've got bromate and we have magnesium. And if you didn't know this was bromate, then just check your sheet and we can find that bromate is right here. And it has a -1 charge. So as we did before, we're just gonna bring the charge up here. We're going to bring it down where there'll be a 1, and we bring the charge here and bring it down and there'll be a 2. So if you do that, we just get a 1 here for magnesium, so we don't need to write the 1. And then we get 2 of the bromate ions. Okay. So how do we name this? Well, we have magnesium and our polyatomic ion, bromate. You might be asking, wait a minute, isn't it magnesium 2? No, it's not magnesium 2. We don't write the charge in this case, because if we look over here, well, where here is magnesium? Magnesium is right here. As we can see, it is in the 2 column, which means it has a +2 charge. And notice that there's no other charge here. Magnesium only exists in it can only be paired with a 2+ charge, right? So we don't specify that this is magnesium 2. We don't do that. So this is just magnesium bromate in this case. So next up, we have potassium bromate. And in this case, it's a little easier because we bring down this charge of 1 and we bring down this charge of 1, and they're the same. So we don't have to write any numbers in this case because we don't specify. Remember, we don't say K1 BRO. We don't do that. So this is just going to be K, and we don't need parentheses for the bromate because it's just one of them. So this is KBRO3. And how do we name this? This is just... Oh, that's not how you spell potassium. Okay. Potassium bromate. And that's it for this one. So let's move on to another set of examples. So in this set, our cation is copper, and it has a +1 charge. And then we have the phosphate polyatomic ion, which has a charge of -3. So we can bring this 3 over to this side, and this 1 down here. We don't need to write that 1. And this just gives us copper, and then we write parentheses because there's going to be more than 1. Oh, I almost made a mistake. Sorry. This 3 comes down here, right? So it's going to be 3 copper atoms in this case. And then there's only 1 phosphate, so we don't need to write parentheses. So that is copper 3 PO4. Now, what is the name of the compound? Well, copper, as we know from our nomenclature, has 2 different possible charges on it. In this case, we just have +1. So we just write copper 1. And then our polyatomic ion, which is phosphate. And remember, if you didn't know that, phosphate is right up here in our -3 charge polyatomic ion sheet. So that is the first one. So second one here, we have manganese, and it has a charge of +3. Bring that over here. And hydroxide, which has a charge of -1. So how do we write that? We start off with our manganese, and then we write a parentheses because we have more than 1 of this ion, and there will be 3 of them from the charge of manganese. Alright, so how do we name this? Well, this is manganese, and we know from our sheet that manganese has a 2 and a 3 charge state. In this case, we have a 3 charge state, so we'll specify that here with the Roman numeral 3. And our polyatomic is OH, which is hydroxide. Oops. Hydroxide. Alright. Next we have tin. So we have a +2 charge that we'll bring over here, and a -1 charge that we bring over there. So that will give us SN, which is tin, and NO3 polyatomic ion, and there will be 2 of them. Now, what is the name? Our name is going to be tin, and tin is one of our multiple charge metals. So in this case we have tin 2. It's got a +2 charge. And then NO3. What is NO3? It is nitrate. So this is tin nitrate. Alright. That is that set done. So now we move on to the last set. Alright. So cation is calcium. Calcium has a +2. And we have chlorate, which is a -1. So this +2 comes down here, and the -1 comes down there. Alright. Calcium. Calcium is in the second column of the periodic table, and it only has 1 possible charge. So first let's write our empirical formula. Alright. And then our name is going to be calcium, and no Roman numerals because there's only one state. Calcium chlorate. Okay. Next, we have our cation is ammonium, and our anion is chromate. So bring the 2 over there, 1 over here. Alright. So that means we're going to have 2 ammonium ions and just 1 chromate ion. And how do we name this? Well, ammonium is not a metal. It doesn't have multiple charges. It only has the 1. So this is just ammonium chromate. Alright. And last one we're going to cover here, we have sodium, which is in column 1, and sulfate, which has a -2. Bring the 2 down there, bring the 1 here, and we have Na2. We don't need parentheses because this is just one atom, right? It's not multiple. So we don't need a parentheses for this one. And then SO4. So this is sulfate, this is sodium. And so because sodium only has 1 possible charge, we don't write a Roman numeral. So this is just sodium sulfate. And that is it. So just remember to keep practicing these. I promise you, as time goes on, the memorization of polyatomic ions will become second nature to you as long as you keep practicing. Alright? That's it from me. Thanks for watching.